this problem came from one of the students doing his research on composite material. So he made some carbon fiber composite materials, and then the testing on the tensile strength of the material. Now, he did not prepare whole lot all of these samples. So this one basically says 22 samples. So this is one sample, and then took three, divide that 4. So he made one day 4 samples and then tested it a different time. These are just operator, or you can just say sub samples. So he made one sample, then divide that into 4 pieces and tested them in a tensile testing machine. So these are the data in terms of 1,000 pound per square inch KSI. That came from that carbon fiber composite. So about 312,000 psi that the material he made, the carbon fiber composite, can take. So now, because the composite material is new, there was not much standard of how much the strength. Also, the strength depends on how you make the composite. So there are so many factors. So in case if you have to say what would be the standard value for a carbon fiber composite material like this. So the question is, so you collect this data and you want to see the quality of the data or quality of the composite material. So what type of control chart is appropriate for that? First of all, this is a variable type of data. So variable control chart would be appropriate. We can make R control chart or S control chart. It really doesn't matter. Both of them provide the same information. So I have created this trial control chart using that data, and check the video on how to produce trial control chart, R control chart, S control chart, both in Excel and Minitab. Now if you look at this, there is one point out of control, and something happened that day. This point number 14, I think. This one is the very high strength, which is 330,000 pound psi, which is out of the norm. So we deleted that and then made a revised control chart. So this is the revised control chart. Look like very standard, looks very within control data. So we did our control chart, we revised the R control chart, and then perform the capability analysis. So in this question says that choose a specification limit so that you could achieve the process capability between 1 and 1.3. So check the video on how to perform the reverse capability analysis, and this is based on the reverse capability analysis. So what I did is I choose a value between that two capability value, 1.0 to 1.15. so that's the value I have chosen, 1.3, and then back calculate this spec limit and check the video on the reverse capability analysis, how upper spec and lower spec is calculated from the standard CP value. So that's the upper spec, that's the lower spec, and these are in terms of PSI, KSI, 1,000 pound per square inch, KSI. And then the next question says you're going to create a label that will be glued on each of the materials sent to your customers. The label should contain the following information at a minimum. Calculate this value. So you want to specify what's the mean strength, what's the limit of the strength if they buy this material, what's the standard deviations if they buy this carbon fiber material, what would be the variation in the material, process capability value, and then the probability the customer will still receive a part which is lower than what you stated. So mean strength, if you basically, that's the revised grand mean, which is 310.5. so you can say here, yeah, the mean strength is 310.50 KSI. So if you buy this material, then you're gonna get that. Let me do this just this way. So that's the mean strength. The limit of this strength, basically you do that upper spec and lower spec limit. So you specifying that would be 280.46 and 340.53. So I'm gonna just copy that. That way it's gonna be easier for me to show. So that would be the Control V. So that is the limit of the strength. Now process standard deviation, you should of course write this upper spec limit, upper specification limit, or simply shouldn't say that, should say in a way that general people understand. So you can say maximum strength, and then this should be the minimum strength. So if somebody buy your material, that should be the max and the mean value for this if they buy this material. So then standard deviation of the process, which is sigma 0, which is calculated 7.7. I can simply type that 7.7 KSI, 1000 pound per square inch. And then the process capability, we have used 1.3. Now this is the questions, one of the most common mistaken question in the exam. The probability of a customer will receive a piece that is lower strength than the value of this minimum strength that you have mentioned. To calculate that, you simply use norm dist, and then you're trying to find the area before that lower spec limit. So it will be about 5 out of a 100,000 that you sell will have less than the strength 100,000 pounds. So the probability would be probability of x less than 280.46 would be about 0.000005. So that's the question. And then create trial control chart using MS Excel. So that's a different question. So to summarize this problem, when you're trying to find a new standard for a material or anything, so you collect the sample and then collect some data and then do a appropriate control charts, perform the capability analysis, and then based on the capability analysis, you mentioned there are limits of whatever that. If it's gas mileage, then the lowest and the highest gas mileage they're gonna get if they buy this car. If it's strength, then you mentioned that mean. So it should be based on the revised control chart, and also standard process capability 1.3, and you kind of back calculate this upper spec and lower spec using that process capability. So that's it about this strength problem.